This is the fourth lecture in computer science course. Second and third lecture dealt with information layer of the computing. Fourth and fifth lecture are related to hardware layer of the computing system. In the first part of this lecture, we will learn about the fundamental circuits of computer that perform logic functions. These circuits are called gates. Gates themselves are built from transistors. In first lecture, we learned that second generation of computers began with invention of transistor. A transistor is a device that acts as a wire. That means it can allow current to flow, or as a resistor. That means it can block the flow of current as well. This property of transistor that allow the current to flow or block it makes it work like a switch. It can also reduce the amount of voltage or increase it, which makes it regulator of voltage or amplifier. Transistor performs these functions because of its terminals named as source, base, and emitter. Base determines whether the current should be grounded through emitter or let it flow to the output or source terminal to produce voltage of 5 volts. Transistors are used to construct gates and other computer circuitry. Gates are logic devices that are made from one or more than one transistor. A gate accepts one or more than one electrical signal as input and produces single electrical signal of low or high voltage as output. Inputs can be many, but they will be only of two types, high and low, represented as 1 and 0. Since gates work with only two values of electrical signals, Boolean arithmetic can be used for their functioning, and diagrams and truth table can be used to show how gates behave with specific inputs. There are different types of gates depending on the output they produce using specific inputs. We will learn about the following: NOT, AND, OR, XOR or exclusive OR, XNOR or exclusive NOR, NAND, and NOR gates. A Boolean expression is written according to the rules of algebra. It is a function which will result in either true or false value, 1 or 0 in computers, according to the values of variables and operations being performed. Logic diagram is a graphical representation of a circuit or gate. Each gate has a specific graphical representation, and truth tables list all the possible input combinations and corresponding output of the gate. First gate we will learn about is very simple gate called NOT gate. A NOT gate accepts a single input and produces a single output. Function of this gate is to produce output that is inverse of input. That is, if input is 0, output will be 1, and if input is 1, output will be 0. In Boolean expression, we can write input variable as a and in its inverse as a complement. Or we can place a bar over a variable to show that it is inverted. Logic diagram of this gate is a triangle with inversion bubble at the output. You will see this inversion bubble in the circuits where output of gate is negated. Truth table for NOT gate is very simple. A shows input x is output. For 0 input, output is 1, and for 1 input, output is 0. AND gate can accept 2 or more than 2 inputs. If all the inputs on AND gate are high, output is high or 1. Otherwise, output is 0. For 2 input gate, there are 4 possible inputs: 0, 0, 0, 1, 1, 0, 1, 1. We can use formula 2 power n to find all possible number of inputs as well. Boolean expression for AND operation for two variables is a dot b or a star b, or simply ab is equal to x, whatever the output of the variable is. AND operation is represented with the multiply sign. You can also see the diagram here. Truth table for two input variables a and b and output x is also shown here. If both inputs are 0, output is 0. If any of the variables is 0, output is 0. But if both inputs are high, output is 1 or high. In OR gate, if any of the input is high, output will be high. For output to be low or 0, all the inputs should be 0. For two input OR gate, Boolean expression is a plus b is equal to x. OR operation is shown with plus sign, while operation for AND is represented with the dot or multiply sign. You can also see the diagram of OR gate here. Diagram of NOT, AND and OR gate are unique. You only need to remember these diagrams. Other diagrams are derived from these diagrams. Truth table is shown here as well. You can see the output X for input A and B. Only 0 or low output is produced when all the inputs are low or 0. Otherwise output will be 1. Exclusive OR gate produces output 1 if any of the two inputs is 1 but not both. That means output will be 0 if two inputs are high. Exclusive OR works like odd function for more than two inputs. If number of high inputs is odd, output will be high, otherwise it will be 0. For example, exclusive OR gate with 3 inputs will produce output high if all the 3 inputs are high. Exclusive OR operation is shown with plus inside a circle in Boolean expression. Logic diagram for exclusive OR is same as logic diagram for OR, but inputs are joined by a line. Truth table for exclusive OR gate of 2 inputs and with 3 inputs is shown here. Exclusive NOR is inverse of exclusive OR. Adding NOT gate to the output of the exclusive OR produces exclusive NOR gate. It operates like even function. If number of high inputs is even, output will be high. Since it is inverse of OR, Boolean expression is same but with a bar over the variables, and logic diagram contains inversion bubble at the output. NAND gate is inverse of AND. It is created by putting inverter at the output of AND. Boolean expression is same as AND with a bar line or complement sign with it. And inversion bubble is given before AND diagram to make it NAND diagram. NOR gate is inverse of OR gate. At the output of OR gate, inverter is applied to make it NOR gate. Logic diagram is same as OR but with inversion bubble at the output. Boolean expression is also same as OR gate, but for the purpose of inverting, a bar or a complement sign is applied. Thanks for watching this video. In next part of this video, we will learn how transistors are used to create gates and how gates are used to create combinational and sequential circuits in computers.